Boom. So we're going again. So we have a slightly different diagram here. Again, just to further illustrate the concept of gradients. Right? Now, when we had the situation where for each horizontal movement we had a corresponding vertical movement of 1, then the gradient was 1. So the line would have looked something like this, right? Right? When we had the situation where for each horizontal movement of 1 we had a corresponding vertical movement of 2, then the gradient will look something like this. Right? So you see steeper gradient, right? And then we had the situation where for each horizontal movement of 1 you had a gradient of a vertical movement of 3. So the line looked something like this, etc., etc., etc. Right? So as you make more vertical movements for the same horizontal movement of 1, it means that the gradient will be steeper, which means that it would get closer and closer to being vertical. So eventually you'll reach a point, by the time your gradient reach 4 or 5 or 6, it will be so steep as to almost be vertical. Right? So to go back to the example of driving, right? I don't think any of us would ever have to deal with the steepest gradient we might ever have to deal with driving a car is probably a gradient of 2. Right? Maybe somewhere between 2 and 3. It has some really, really steep hills out there. Right? But we wouldn't have to deal with gradients of 3, 4, and 5 and things. That is not car story. That is spaceship scene you're talking about now. Right? Launching a ship into space, etc. So you can launch it either perfectly vertical or maybe at a slight angle. Right? So all of that is areas where you could see the whole idea of the gradient coming into play. Good. Now, it is not always the case. Now, of course, this same idea would work if the horizontal movement was to the left, which would make the gradient negative. Right? Now, it is not always the case that you would have a movement of 1 or 2 or 3, or even somewhere between 1 and 2. So for example, for the same horizontal movement, you might move 1.5 units up vertically, which means that the line would pass somewhere between the gradient of 1 and the gradient of 2. Good. Suppose after one horizontal movement you only make a vertical movement up of 1/2. Right? So we're going to illustrate that now. It'll be half right here. Good. So for the same horizontal movement, your vertical movement is 1/2. So it means that your line will pass through this point here. Right? So your gradient now will be equal to 1/2. So you see the line with the gradient of 1/2 is actually below the line with a gradient of 1. Right? And then suppose for the same unit horizontal movement, your vertical movement, let me say, is 1/3. No, let me say 1/3. Let me make it a quarter, so easier to divide. A quarter, right? It means that you come in here, right? So this will be what your gradient will look like, right? So again, you see the movement, right? The movement down. So this is a gradient of 1. The m equal 1. We will explain the significance of m at a later date. Right? In this line, the gradient was 2. In this line, your gradient was. Here now, your gradient is 1/2. And here, your gradient is a quarter. Right? So again, you see the clear pattern where as the gradient increases, the line gets more vertical, and as the gradient decreases, the line gets more horizontal, which is then to say that the gradient of a horizontal line would be m equal 0, and the gradient of a vertical line would be m equal infinity, right? So between the extreme limits of 0 and infinity, you have a whole spectrum of gradients. Good? And then the same thing, of course, naturally would happen on the negative side. So the gradient will be 0 because 0 is 0, right? We don't waste time talking about minus 0 and plus 0. So that is 0 there, and then you go all the way up to a gradient of infinity. Good? So that's basically it. That's basically it. So from a visual, from an intuitive standpoint, we want to be able to get a clear grasp of what gradient is. So anytime somebody says they have a line of gradient 1, you're supposed to have some kind of picture in your mind of what that look like. It might not always be a clear picture, but if you have enough familiarity with these diagrams, you would know that 1 would be something like this. 2 would be, you start from 1 always. Start from 1. And that's a general principle in most of mathematics. You start from 1 and then you build out from there. So starting with your unit gradient, let me go in black now just to demonstrate the point, right? So your gradient of 1, m equal 1, right? Right, that's your unit gradient. So from your gradient of 1, then 2 will be like this and 3 will be like that, going up the road, and then the gradient will be a half, a quarter, etc., etc. Now, here is where the discussion going to get even nice, and I'm going to throw in something here now that you may not necessarily have to use in the exam, but is good knowledge to have, and it will help in your overall understanding of the thing. So if I have a line like this, and for every unit horizontal movement, the vertical movement is, let me say, 2, right? Well, let's see where I'm going with that, right? Horizontal, vertical, so clearly that will be a right angle there, right? Which means then that the angle that the line forms with the horizontal, let me call this angle alpha, right? The angle that the line forms with the horizontal, the tangent of that angle would be the vertical movement over the horizontal movement. In the language of trigonometry, the opposite over here, adjacent, right? So in your general consideration of angles, the gradient of the line is the tangent of the angle that the line forms with the horizontal, right? Remember, in general, the gradient of a line would be the vertical movement for each horizontal movement. In other words, and I'm going to throw in another concept here now, the ratio, that word again, the ratio of the vertical movement to the horizontal movement, right? So basically what you do is divide the vertical movement by the horizontal movement for the line, and that is your gradient. Of course, if the line were oriented like this, then the gradient, the ratio will be the same, right? Let me say alpha is the same, right? Same angle, same 2 over 1. Yeah, that's looking more like 2 over 1 than this one, right? The difference, however, is that in this case, we will ascribe a negative sign to the gradient. So while the gradient here would be minus 2, the gradient here would be plus 2. However, the angle would be the same. So in other words, in this little example in the corner here, the difference between plus 2 and minus 2 allows us to differentiate between a line that is oriented like this and a line that is oriented like this, because the ratio is the same. For each horizontal displacement, you have the same vertical displacement of 2. Alright? So the minus sign gives us a little extra information that will allow us to see the orientation of the line, whether it's going so or whether it's going so. All right, so that's the basic idea. That's the basic idea. Now we're going to apply this to the consideration.